In this video, we are going to look at the inverses of the functions sine, cosine, and tangent. All right, so first let's go back, remember some of our unit circle stuff. Let's look at the sine of 45 degrees. So I've got our 45, 45, 90 triangle drawn here for us. And let's go ahead and put some values on that. If you guys remember from our 45, 45, 90 triangle, the sides, the legs are 1 and 1. And the hypotenuse is square root of 2. Hopefully you remember those values from what we had learned before. So the sine of 45, sine is opposite over hypotenuse. So from our 45-degree angle here, opposite over hypotenuse. And then you guys remember we had to rationalize that. We had to get rid of the square root that was in the denominator. And so we get square root of 2 over 2. So in this case, sine is our function. We give sine an angle value, and it gives us a rational value back. It gives us a ratio opposite over hypotenuse, which sometimes we have to rationalize. So now the inverse should do the opposite. The inverse, remember, should take this value that's our ratio, and it should return to us an angle answer. But for the trig values, there's something else that you have to keep in mind. Look at our unit circle here. So I've got all students take calculus as a reminder. And you remember that sine was positive here in the first quadrant. Well, that's where my 45-degree angle came from. But sine is also positive in the second quadrant. So very often when we do the inverse of our trigonometric functions, the directions will say give all the angle values between 0 and 360. Right, that's a less than or equal to there. Sorry, it didn't turn out very well. And so we're going to have to give two answers because we're going to have to go all the way around the unit circle to both quadrants where this particular value is positive or negative. All right, so let's look at it right here. All right, so you can see our -1 there, sine inverse is what we have. It has a special name. That's also called arcsine. So you might see it this way on college placement tests. You might see it this way. Could go either way. They mean exactly the same thing. And this is just asking you what angle has a value for sine of square root of 2 over 2. Remember that this is going to give you an angle answer. Okay, so we already did one. The sine of 45 is square root of 2 over 2, so I'm going to put 45 degrees right there. But remember, sine is positive in two quadrants. We gave the first quadrant answer. We need to also give the second quadrant answer. Okay, so what was this value right here? 45 is our reference angle. We're 45 degrees away from 180. 180 minus 45, 135. So our two angle answers that we would get for inverse sine or arcsine are 45 degrees and also 135 degrees. All right, let's do another one. This time, let's look at cosine. All right, so I've got our 30, 60, 90 triangle here. Let's see if we remember the values for the sides of that one. So remember, the smallest angle is across from the smallest side. That's 1. The hypotenuse was double that. That's 2. And then the long leg over here was square root of 3. So I've got 1, 2, square root of 3. All right, if I want the cosine of 30, all right, cosine. Cosine is adjacent over hypotenuse. So here's my adjacent side. Here's my hypotenuse. Cosine of 30, square root of 3 over 2. Nothing to rationalize there, right? It's already got a rational number in the denominator. Okay, so now let's do the arc cosine or the inverse cosine down here. And this time I'm going to give the ratio, right? I'm going to give this one, and it's asking you for an angle answer. Arc cosine or inverse cosine is always asking for an angle answer. So what angle has a cosine of square root of 3 over 2? Well, we know that's going to be 30 degrees. And I also know that cosine is positive in two quadrants. We've got the first quadrant answer here of 30 degrees. I also need to go around and give the fourth quadrant answer. So here's my 30-degree angle. The reference angle right there is 30 degrees. So what would be the positive value if I go all the way around the unit circle and I stop right here at 30 degrees short of making it all the way around? So I need to find out what this angle is. This is 360. 360 minus 30. 330 degrees. So my two angles that answer this question are 30 degrees and 330 degrees. The two angles that are the inverse are these two angles right here. All right, let's do a tangent one. All right, so I've got tangent of 0 degrees. Okay, so remember these were a little bit different. These we had to look at, instead of the triangles, we had to look at the coordinates of the point. Okay, so here's 0 degrees right here. The coordinates of that point, well, the x value is 1 and the y value is 0. All right, and you remember that the x value goes with cosine and the y value goes with sine. And tangent, if you remember we did the ratio for tangent is opposite over adjacent. That is true, but not helpful when we don't have a triangle. The one we want to look at when we don't have a triangle is that tangent is equal to sine over cosine. So in this case, remember sine is our y value, cosine is our x value, y over x, 0 over 1, and 0 over 1 simplifies to be 0. So tangent of 0 degrees is 0. That's our ratio right there. Opposite over adjacent, if you want to think of it that way, or sine over cosine. Okay, so let's look at this. What angle has a tangent of 0? Right? Because remember, when I do inverse tangent or arctangent, I'm asking for an angle answer. So what angle has a tangent of 0? Well, I know one of them is 0 degrees. So where else does sine equal 0? Well, sine is going to equal 0 when I'm on the x-axis. So my other answer is going to be right here. If I start at 0 and I move around to here, 180 degrees has a tangent of 0. So therefore, the inverse tangent of 0, two possible answers, 0 and also 180. Now, I could go around and also say this one at 360. Sometimes professors or computer programs will ask for that one. Sometimes they won't. So you just have to watch what they have in the question. If they write it like this, right, you see there's no equal to right there, so they don't want 360. If they write it like this with the equal to, then they do want 360. So you just have to watch out for that kind and see what answer the computer or the professor or whoever you're working with is asking you for. Okay, let's switch a little bit, and instead of doing degrees, let's do some answers in radians. So I've got the same kind of question. What angle has a sine of negative square root of 3 over 2? Okay, so where are my negative values for sine? Well, sine is positive here in the first quadrant. Sine is positive here in the second quadrant. So sine is going to be negative in the third and the fourth quadrant. So I know I want values down here in the third and the fourth quadrant. The question is, what is my reference angle? So let's see. And I'm going to do the 30, 60, 90 triangle here. So 1, 2, square root of 3. All right, and then sine, you remember sine is opposite over hypotenuse. So the one that's opposite the square root of 3 is 60. And if you don't remember how to do the reference angle in radians, you can always multiply by 180 over pi. Remember how we changed those? And we got pi over 3. So my reference angle is going to be pi over 3, and I want that pi over 3 radian measure to be here in the third quadrant and here in the fourth quadrant. Okay, so let's see. Do you remember how we did this when we talked about the numerator and how it relates to the denominator? When I move into the third quadrant, the numerator is 1 more than the denominator. So 4 pi over 3 is my first answer. That's my third quadrant answer. And then in the fourth quadrant, you remember we said we were almost over here to 2 pi. So we had to multiply the denominator by 2 and then subtract 1. 2 times 3 is 6. 6 minus 1 is 5. So 5 pi over 3 is my other answer. So those are my two radian values where the sine of that angle is negative square root of 3 over 2. And any of you guys who go forward to take calculus, this is the type of answer your calculus professor is going to want from you. Very rarely are calculus professors going to allow anything in degrees. They're going to want almost everything in radians, so that's why we need to practice. All right, let's do one with cosine. All right, so I've got cosine equal to 0, the angle that gives me a ratio with a 0. So where is cosine going to be 0? Well, remember, cosine goes with x, and your x values are 0 on the y-axis. So my two answers for this one are going to be here and here. Okay, so now let's think. A couple of different ways we can do this. If you want to think in degrees, how many degrees is a quarter circle? Well, that's 90 degrees. And then I can multiply that by pi over 180 to change it into radians. And I get pi over 2. That's one way of doing it. Or if you think about this part of the circle being pi radians, right? 180 degrees is pi radians. And this is half of that. So half of pi is pi over 2. And then this one over here, I went another half pi right there. You can see I went past pi radians, half a pi. And so that one is going to be 3 pi over 2. So my two possible answers, pi over 2 and 3 pi over 2. Okay, so again, those of you guys who are going to take calculus in college, this is the type of answer your calculus professor is going to be looking for. I realize that 90 and 270 are equivalent to that, and they are the same thing in degrees, but very often calculus does not focus on degrees at all. It focuses only on radians. All right, last one. Let's try this one. Tangent inverse of 1. So what angle has a tangent of 1? Well, you might be tempted to look at your quadrantal angles. Those have the zeros and the ones, but think about tangent. Remember, tangent is sine over cosine. So when this equals 1, that's when my sine and my cosine are the same. Well, that means that my opposite and my adjacent sides are the same. Well, what angle has adjacent and opposite sides the same? That's our 45, 45, 90 triangle. So I'm going to take that 45, 45, 90 triangle and I'm going to give a radian answer. Okay, so 45 degrees in radians. You remember what denominator always went with 45 degrees? That was 4. So right here, I've got pi over 4. Okay, is that sufficient? Well, no, because tangent is positive in 2 quadrants. I've given the first quadrant answer. I also need to give our third quadrant answer. Okay, so remember the relationship between the numerator and the denominator. When I'm in the third quadrant, the numerator is 1 more than the denominator. So there's my two angles, pi over 4 and 5 pi over 4. Now, of course, for purposes of this class, if you need to think about that as 45 degrees and 225 degrees, and then you need to change both of those into radians by multiplying by pi over 180, that is going to be perfectly fine. You're going to get that same 5 pi over 4 answer. I just want to kind of prompt you for where you're going with calculus and get you to start thinking this way in the first place instead of having to go through degrees. But right now, while you're just learning how to do it, if you need to go through degrees to get the radian answer, that is perfectly acceptable.